In this problem, we're asked to mark all of the following, which are Cauchy-Euler's equations. So when we look at this, the ones that are already highlighted are not necessarily correct. But we are going to look to the right here, where we have this kind of formula that we can always look at. And this is how to solve any Cauchy-Euler equation, or to how to make sure before we even start solving if it is a Cauchy-Euler equation. So when we look at this, we are going to look at our n's above the x and y, the exponent. So when we look at this, we're going to look at the exponents above our x and y. These exponents have to be the same. It's very important. They have to be the same. And when we go down here, when we look at this one, our x is really being raised to the 1 power, but we don't really put that ever. It's just x for itself, and we have the y prime. For this one right here, our y is 1, and our x is x to the 0th. So we really have an x0 right here. But we don't really put that. These two are important to keep in mind though. Everything else, it's going to be the same throughout. And it's important, I wrote this note down here, that all of the a's just represent constants. So there's just any constant in front of it. It does always have to have a constant. However, that constant can be 1. So if you don't see a number in front of it, the constant is just 1, and that's fine. There can be no constants on their own though. That's why we have a 0 right here. If we do have any constants, which we will actually see in this example, then it's not a Cauchy-Euler equation. Now looking at these, I'm going to go one by one and part by part. For the first part, I'm going to be looking at this. Well, this is not a Cauchy-Euler equation because our x is being raised to the 4th and y is being raised to the 7th. Since they have different exponents, this is not a Cauchy-Euler equation. If we look at the second part, our 7 times x cubed and then y cubed, this is a good Cauchy-Euler equation. And so is this part right here. And so is this part. However, since we have one that's not, this is not a Cauchy-Euler equation. When we look at part B, we're going to look at this x cubed, and we basically have a y cubed here. This d raised to the power of 3 times y over dx cubed is basically saying y cubed, or the derivative of y cubed with respect to x. This is good because our exponents are the same. Now we're going to look at the next one. This one's also good because the exponents are the same. And when we look here, we have a constant, an x to the 0, and then a y, and then equal to 0. So this is a Cauchy-Euler equation. Part B is good. Now we're going to look at part C. In part C, we're going to see that we have an x squared times a y double prime. This is a part of a Cauchy-Euler equation. This is good. Our exponents are the same. We look at this part and we have an x times y prime. We know that this is going to fit this part right here, so that's going to be okay as well. And then we have a 9 times y equal to 0. So this is good right here. Now we look at D. For D, we have a constant times x to the 7th times y to the 7th. Since our exponents are the same and pi squared is just a constant, this is okay. Next, we have a 7 times xy prime. Well, again, if we look at kind of what I wrote out here, we have a constant times x times y prime, so this is okay as well, and that means the rest of this will be okay as well for the same reason, so D is our option. So far we have B, C, and D as our Cauchy-Euler equations. Now we are going to look at E. For part E, the exponents are the same here, exponents are the same here, and then we have a 5 times x to the 0th power times y, and then a constant 0. So E is also a Cauchy-Euler equation. So far we have B, C, D, and E that are Cauchy-Euler equations. Now we're going to look at F. For F, our exponents are the same here, 7 and 7. However, when we look at this next part, we have some issues. And the issue is just one, and it's with this e to the x. If this e to the x were not here, then we'd be okay. However, since it is here, we have an x, which gives us an error, so this is not a Cauchy-Euler equation. This 6y is okay, and so is this constant 0. So other than our second part, it would be, but because of the second part, because of the ex explicitly, it is not. Now we are going to look at G. In part G, we have x cubed times basically a y cubed, plus a constant times x to the 7 times y double prime. Since these two powers are different, it is not a Cauchy-Euler equation, so G is not. In part C, when we look at this, we can see that we have an x squared times a y double prime. This is okay. We have an x times y prime, so looking at this is going to be the same as this, which is also okay. And then we have a 9y, and this looks good for this part right here. However, the only issue is that we have a constant in here that's not linked to an x or a y. And since we have a constant in here not linked to an x or a y, it is not going to be a Cauchy-Euler equation. And obviously it's also not none of the above. So the only Cauchy-Euler equations that we have are B, C, D, and E. And that's how you start by solving any Cauchy-Euler equation. You have to prove that it is one to actually start solving for it.